In this video, we're going to review how to factor polynomials and solve polynomial equations or define the roots of polynomials. So first of all, I just want to remind you some of the steps when you're factoring a polynomial. The first thing you always want to do is look for a GCF. So that's always your first step. So always look for a GCF. And then second, if you have binomials, so if you have two terms, if a binomial, you want to look for difference of perfect squares. So look for difference of perfect squares. We will not be factoring with imaginary numbers. You don't need to worry about that. So I'm just going to put a note. So you strictly want difference of perfect squares, not sums of perfect squares. So I'm going to say don't need to factor with imaginary numbers. And then for number 3, if you have a trinomial, so if a trinomial you want to either use the box method or just the grid method or just looking for numbers that add to the middle term, multiply to the last term. So I'm going to say grid method or find numbers that add to B and multiply to C. So meaning if it's ax squared plus bx plus c. So then the last one here, if we have 4 terms, you're going to use factor by grouping. So that's where you split it in half, and then you factor out a GCF out of each part, and then you factor out the whole binomial from there. And then lastly, just a reminder to always factor completely. So if you end up with a binomial that is a difference of perfect squares after you do factor by grouping, well, then you would want to continue factoring. So factor completely. So I'm going to skip these warm-up questions here because these are actually a review. Really, this whole factoring is a review from previous units. So what I want to do is I want you to practice these. So you can go ahead, you can pause the video, try these, and then you can check your answers using the answer key. And then what I'd like you to do is come back and watch the rest of this. So the second half of this is actually going to be where we're solving. So on the front page, it's just factoring. You're leaving your expressions as a product of factors. So no solving. Here it says find all the roots. So finding all the roots means you're actually solving. So we're going to solve for x. So this means, notice now we have equals 0. So now we can actually factor these, and then we can set each part equal to 0 or each factor equal to 0. So if I look at this first one, number 7, I see that this is a 5th degree polynomial. So that means that there's 5 total roots. So 5 total roots means I could have a combination of some imaginary roots if in conjugate pairs, and then whatever else is left would be real roots. So what we want to do is we're going to start by factoring. So thinking about the rules from the first page, we want to take out a GCF. I could take out an x. So I'm going to go ahead and take out an x. So x to the 4th minus 5x squared plus 4. And now this inside piece is 3 terms, so trinomial. So I'm going to look at this as kind of think about it the same as I would if this was an x squared with an x and a number. So what I'm going to do is I'm going to separate this, except for instead of having just an x and an x, it would have to be x squared and x squared. So I'm going to look for numbers that add to -5, but then multiply to 4. So that's going to be -1 and -4. I'm going to keep my equal 0 at the end. And now these are difference of perfect squares, so I can factor those further. So that's going to be x plus 1 and then x minus 1. This is going to be x plus 2 and x minus 2. And now that this is a product of linear factors, meaning all of these have been factored completely, and it's a product equal to 0, I can set each piece equal to 0. So I'm going to go ahead and split all of these up, and I'm going to end up with x equals 0. I'm going to have x plus 1 equals 0, which is just going to be x equals negative 1. X minus 1 equals 0, so that's going to be x equals 1. X plus 2 equals 0, so that's going to be x equals negative 2. And x minus 2 equals 0, so that's going to be x equals 2. So basically what I have here is the factors are up top. These are the roots or the solutions. So notice basically all of the signs just flipped. So here are all of my 5 roots for this equation. It says to classify each root as rational, irrational, or imaginary. Well, all of these are real numbers, and they actually all end up being rational. So these are all real, rational roots. And just so you are aware, the discriminant does not work for these polynomials. So just be aware of that. If you remember the discriminant, we use that to classify the nature of the roots for quadratics. That does not work when we're talking polynomials. So that's only for quadratics. If I look at this next one here, I think I'm going to actually leave that one for you because it's very similar. Look for GCF, but remember you have 6. So that means an exponent of 6, degree 6 means there's going to be 6 total roots. So it's going to be a combination of some real, some imaginary. Imaginaries have to occur in conjugate pairs though. Okay, so I'm going to leave that one for you. And I think the only other one I really want to look at with you is the factoring one. Well, if I look at number 9, just to talk through that, you're going to factor out GCF, so you could factor out an x and then from there continue factoring. But if I look at number 10, I just want to talk about the factoring of that because when I first look at this, I can't take out a GCF. So now we have a situation where we have this trinomial that has, again, degree 4. So I can go ahead and I can still use the grid on this. So I just wanted to show you that because I'm looking for numbers that are going to add. So let's go ahead and just write this out. So I'm looking for numbers that are going to add to 9, but they have to multiply to the product of 4 times negative 9, so negative 36. So then we put the first term in the first box, so that's going to be 4x to the 4th. Last term in the last box. And now we're looking for numbers that are going to add to 9 and multiply to negative 36. So 12 and negative 3 would do that. So negative 3, it would have to be x squared because remember we have to add to that middle term. So negative 3x squared and 12x squared would, if you combined this entire inside of the grid, you would end up with this trinomial. So that's how I know I'm doing this correctly. Now I can GCF factor, so I'm going to take out an x squared, and then I'm left with completing the multiplication. So this is going to be a 4x squared. X squared times what gives me negative 3x squared, so negative 3. 4x squared times what gives me 12 x squared, so that's going to be plus 3, and then check the last. So 3 times negative 3 gives me negative 9. So now I can rewrite this as 4x squared minus 3 times x squared plus 3 equals 0. So you could factor these further, but they wouldn't be over integer values, right? So 3 is not a perfect square, so I don't really want to use difference of perfect squares here. Same with this one. I don't want to try to factor this over imaginaries. I just want to go ahead and say they don't factor any further, so what I'm going to do is I'm just going to set these each equal to 0. So I have 4x squared minus 3 equals 0, so I can go ahead and split that product right up. And then solve them. So I have 4x squared equals 3, divide by 4. And then remember, you're square rooting an x squared, and you should be expecting to get out 2 solutions. So this is going to be x equals plus or minus. This is the same thing as saying root 3 over root 4. So this is really root 3 over 2 because the square root of 4 is equal to 2. And then over here, I have x squared equals negative 3. So square root both sides, so I get x equals plus or minus, this would be I root 3. So here are my 4 solutions. Remember, I expected exactly 4. Notice that 2 of them are real and the other 2 are imaginary. Imaginary have to occur in conjugate pairs, so if you have 2 imaginary, well then the other 2 would have to be real, or if you had 2 reals, the others have to be imaginary. So to classify these, I have 2 real irrational roots, and so 2 real irrational and 2 imaginary. Roots. All right, so I think that gives you enough guidance here to get started. Remember that the answer key is posted as well under the answer key section, so feel free to use that if you get stuck. I do want to point out though that if you get anything that's a double root, make sure you classify that as well. So meaning if I end up with, like, just for example, don't write this, but if I end up with, let's say, x squared equals 0, when I solve this, well, there's not really a plus or minus 0, right? So this just means that x equals 0 is a double root. There's 2 x equals 0s, which means it's the graph's tangent at that point. So I do want you to classify that if you do end up with a solution, which I think you will. So just be careful of that. Otherwise, give them a try, and then the homework is the next page. So you're just finishing up pages 9 through 11 for this section. Have a good day, guys.